Okay, so hello everyone, and the topic today is Kittehs on Temporal. Why Kittehs?
Because I suck at names and I love cats.
Yeah, and this is where our name comes from, Autokitteh. So if you were wondering, that's it. And so what we're building is an open source developer first framework for versatile automation, and this is exactly what we're going to explain to you and show how we are doing this. Okay, so briefly about myself, I'm coming from a background of development and product management, cybersecurity, networking, PhD in computer science, and I know Itai for 20 years now or more.
Mm-hmm. His real name is Med Scientist Dr. Autokitteh. But oh well, my name is Itai. I've been working in many fun companies, which last one is Checker, which there I got to know Temporal. And let me say one thing is that the workflow in Checkers are extremely sophisticated and complicated. And it got me to know Temporal really, really intimately. And I love Temporal a lot. And I think they just find the right abstractions, which is awesome. And we are betting our thing on that. Previously, I have experience in architecture, backend, configuration, developer productivity, and a lot of stuff that require really in-depth automation that's being done in a reliable manner. So this entire thing is actually a result of a lot of pains that I felt during my time in my entire career for more than 20 years, that I always wanted. I needed this tool to do this thing, but it's always so complicated. So I wanted to fix this. So it all started in Lyft, in Review Kitteh. That's just a simple, very simple automation that I wanted to do as a part of a hack week. That's all it does. It's very simple. You write meow in a PR comment for one of Lyft repos and mention a few people, and it will go to Slack and bug them personally using this message. This is an actual message, by the way, that screenshot from there. It grew very, very popular. I didn't advertise it all, it just grew exponentially. And the problem is that I thought it will take me a bit less than, let's say, a day to do it. It took me a week. And that's a common story. Why it took me a week? Because deployment and development with integration with weird APIs and authentication and monitoring and going to production and all this stuff. We all know this story and don't love this story at all. Kitteh is the next thing that actually came to mind. I knew Matt Klein, who is the originator of Envoy Proxy, if you know this project, one of the most popular projects in GitHub. And I told him, hey, wouldn't it be cool if you had some kind of file in the root of the repository, like Travis CI or whatever, that you define in very simple code the automation you need for the repo, and whenever it comes and get a GitHub event, it will actually act based on this file. It said, this is an awesome idea, do it, I'll use it. I did it, use it. We celebrated, I don't know if celebrated, but 5 years since it's actually in use in Envoy. I know this because the certifications expired, so that's a good thing. And not a good thing, but it's a good reminder. But then I think it should be something much more than that. We all know GitHub Actions, which are a less savory approach to the issue, and they're hard to write, and execution them is pretty slow, but they're awesome for CI related stuff. This is more for, the Kitteh was designed for more quick, snappy stuff, but it's not enough because we need to add many more things about it, right, Chaim?
Yeah, so automation, when we think about it, actually terminology is a bit confusing, automation, orchestration, workflows, but what we're talking about is basically connecting various systems through APIs, like a distributed system. And this goes for all kinds of automations. It can be development processes, development management processes, like I mentioned, connecting GitHub and Jira and Slack and so on. Or it can be things related to DevOps, and we spoke with so many DevOps. Each has its own problem to run workflows, which are also reliable and so on. It can be office automation, or it can be even enterprise workflows. Many of them can be durable, right? Using even internal tools like Salesforce and even ChatGPT. And of course, you can always build your own workflows, even using gRPC and HTTP, and they have to be durable, right?
Mm-hmm. Yeah.
So, cool. So you want to build something versatile in automation. But if you think about it, and you have this problem, you want to automate something. So what will you do as a developer? So actually,
what can you use?
Yeah, what can you use?
What can you use,
What can you use? So you can think about it as two axes, as two measures. So first of all, you can think, okay, what coding skills do I have? Am I like this tiny little cat, or very beginner, or I don't want to develop code, or use some, maybe I'm not even a developer, or I can be a citizen developer, or a professional, or to be this professor cat and do whatever, anything I could think of. So this is on one side. On the other hand, you can think about the versatility of the complexity of what you want to build. And can be very simple things or very complicated things, right? Okay, so once you have that, let's see what tools do we have. So for building quite simple automations, you have tools like, amazing tools by the way, like Zapier and Make and Ift and Retool and Pybream and many others. They are great tools, but they have their own limitations. In most cases, they use DAG, the directed acyclic graph. In many cases, they're limited in time. They're not durable. So each of them has its own limitations. Typically, it's not code. On the other hand, you have those amazing tools for doing reliable, long-running automation. You have step functions, Airflow, and of course, Temporal. By far, I guess, the most suitable things for this. But it's for professionals, and you need to know some stuff about it, right? You cannot just go and develop automations if you need something simple or basic, just directly on this. Or you can do anything on your own if you're an artisanal.
Yeah, notice one thing, that Temporal has quite a steep learning curve. It's very much worth learning this learning curve, because that's something that I think Temporal, they found exactly the right abstractions. And knowing exactly what workflows and activities and how to map everything to that's extremely important. But even before Temporal, notice that the artisanal way, that the expert, they are always grumpy because it's so hard. Distributed systems are exceptionally hard, and anybody who's trying to tell you otherwise is selling you something, right, Chaim?
Right.
Like
right.
us.
So
Yes.
Imagine this. Think you could write code, just code in Python or other language, and this code will take out the complexity of distributed system. It will take care for you for retries, for state management, for observability, and all those other things, okay? And just imagine this. We call this automation as code, which is kind of weird, right? Because automation is typically done with code. True, but to develop distributed system today, it's not only writing code, it's a lot of infrastructure behind this.
A lot of DevOps.
A lot, not only DevOps, all kind of things. So to develop an automation, of course, you need to write your code, right? And test it and all of this. But then you have to take care of APIs and authentication if you're connecting external systems. You have to take care of some global, maybe sharing data between APIs, then between workflows. Then you have to have databases to connect and share information. Then you have to take care of error handling, which Temporal do amazingly. Error handling and recovery from failures, state management, all of this. Then you have to take care of code management and visibility and auditing and all of this. And above all of that, you have to deploy it somewhere. Right? So now you are DevOps, and where do you deploy it, and all of this. And this is only a development phase. Then you have the execution phase, where you need to take care of visibility and monitor everything, and what's wrong, what went right, and so on. So it's a lot of things. So think about it this way. What we're saying basically is, why wouldn't we build a system that provides an abstraction layer that hides all this really complicated, not only complicated, but tedious stuff that you have to do over and over again, and leave the developer writing only the code, and let the system take care of everything else. Okay? This is basically our vision.
Yep. Finding the right abstraction.
Finding the right abstraction. So this is what we're doing in Autokitteh, and let me explain to you how we do this.
Not you, me.
You explain.
Yeah.
Of course.
And so this is my part, Chaim.
Go ahead.
Yeah. So this is the architecture of the design of around what we're trying to do. So we are first building on Temporal. It can be Temporal or the command line Temporal that you can run locally. Our vision, it can be run anywhere. And on top of the Temporal, the core components, we have our components. One of them is slow down. One of them is the backend, which is the main server, which is kind of parallel to the Temporal server. And we've got the workflows and activity. The workflows are actually implemented, being driven by something we call runtime. And the runtime actually is the thing that you write the language is. It's the thing that's responsible of I would say, translating between the code that you are writing, which will be very straightforward, to the actual activities that are being run and what the workflow should be doing. The runtime and the workflow has a very, very clear API between them. So you can swap this runtime and use it for something or some other runtime, or even combine runtimes in a multi-language architecture. For example, you could write some of the code in Python, and your other code, you can describe a DSL or your own specifically designed DSL and just tailor it into the system. The system is built to be composable and extensible. Another thing that is extensible is the integration. We supply some integrations, but we let the users very easily, I hope, to add their own integration using a very simple API. So let's say you have an integration with some kind of internal system, you can write your own integration. And better yet, if this system, let's say talking with gRPC, we have the ability to actually just point Autokitteh to the system and it will automatically learn about this RPC and build actually on the fly the integration for you during runtime, which is quite powerful for enterprise integrations. All these systems can be are API first, and they have CLIs. And we also supply, hopefully someday, Cloud IDE. And currently we integrate quite well with at least Visual Studio, which I'll show you in this demo.
Yeah, so now we decided to go brave, and we're going to show you a live demo.
So brave Kittehs.
We're very excited because this is the first time we're showing what we're doing. So if there will be some hiccups, please forgive us.
Yes.
But let's hope.
Yeah, it's really rough on the edges. It's designed for the demo. We just started working on this seriously. We worked for it a long time, but oriented for the demo of the last few months. So yeah, let's see how it goes.
Let's see how it goes. Let's see.
Let's give a silent prayer for the demo DTs.
So just to give you some context, let's say you want to build something quite simple, the thing that Itai built for a week back then, a couple of years ago, that when somebody does a pull request, it will trigger a workflow. The workflow will parse the message, see whether it fits, and then notify users in Slack. Okay, pretty simple, right? So let's see how it works.
Oops. Oh, there you go. So first thing, we need to start Autokitteh up. So Autokitteh is just a simple binary that you can just bring with you anywhere. It has got no dependencies. So the first thing we're doing, and I need to enlarge the window for full effect, is get the Kitteh up. So Autokitteh is up and is serving traffic and is waiting for us to actually ask it to do some stuff. So first of all, we'll talk about the manifest kind.
Yeah. So what you see here, this is a cool integration of Autokitteh inside Visual Studio. So we figured out this is you're a developer. Many of you probably use Visual Studio. It should be built in. So to build an automation, actually, you need to do a couple of things, right? First, you need to define the APIs or the connections to the APIs you want to work with. If you want to work with GitHub or Slack or whatever, you have to define and provide credentials to being able to work with them, right? This is very clear. Second thing, of course, you need to write your business logic, which hopefully will be quite simple, hopefully. And then you need to tell the server basically, okay, take all of this together, make some configuration, and we define it in a file we call manifest that defines this integration, this automation, and what exactly it does. So let's see how it's implemented.
Yeah, so let's talk about the components that I mentioned earlier. First, we're creating a user named George. And this will, when you apply the manifest, everything here will be created and set up for you. And we create a project called Review Kitteh. We can also see that we already have by default an account called Autokitteh with a few integrations that are ready to be set up. So when we created a project Review Kitteh, when we apply it, it will be created there. We tell it to use file from the Review Kitteh directory and start with the main.star file. That's the first file. And then we're going to create new connections. One is Slack and one is GitHub, that connect to our integrations. That one of them is based on the Autokitteh Slack, and one of them is based on the Autokitteh GitHub. You see there's also other stuff that we'll not be using now, but we're very happy to show you later if you come and would like to talk more. And so after we set up this connection, we'll talk about the tokens a bit later. We're setting up environments, and Chaim really loves talking about environments.
Yeah, so we as developers, we usually work with environments, right? Because we want testing, production, and so on. So you can have, so here we have one example of production, but you can have multiple environments working together.
Yeah.
Let's see.
So this is one
of
the environments. We call it prod, we could call it demo or Moishe, it doesn't matter. The vars, we define an environment variable called channel. This is the channel ID of the Slack channel that we want to send messages to. We also define a trigger. Here it's called mapping, but it's a trigger that's coming from GitHub. Whenever we get an event from GitHub and it's a pull request event, we are going to launch this function. So first, let me apply this.
And by applying basically what it means, it kind of compiles everything together. It makes sure that we have the automation we need and we can run it on the server.
Yep, and it sets everything up. And now we see we have a new thing here called George and a Review Kitteh project. We've got a production environment. We currently got no deployments. And we got Slack and GitHub connections. We can see that Slack supports these operations, for example, for instant chat post message. Chat post message, receive channel, text, and optional blocks, thread yes, and reply podcast. So if you go to the files now, and we open main.star, we can see that this is the code that we've written. This is essentially written in a language called Starlark, which is essentially a simplified Python. You can essentially do anything you want in Python, you can do here. We're also going to support actual Python, and we're going to support also JavaScript, TypeScript, very high on our priority list, and other things as well. Or your favorite DSL if you want, or just YAML or stuff like that. So what happens here is that we load channel from the environment, and we tell Slack we want to use your chat post message facility. And when an on GitHub request operation happens, we are going to post a message to Slack. Now, there are several kinds of magics here. One of them is this is actually defines a workflow. You don't know it, and you don't need to know it, but because we are all in temporal convention, obviously it's very interesting. What happens is that when we define the on GitHub pull request, we actually define the workflow. Everything that happens here is actually running as a workflow. And the chat post message, when that happens, we automatically run it as an activity. Think about it, we define some kind of a graph here that you actually have no idea about. And when we're executing this graph, we're actually executing workflows and activity. In this case, one workflow and one activity. Chaim, do you want to see this running?
Yeah, let's go.
Do you want to see this running?
Yeah.
Oh, great. We have live people here. Yes, you're a good quad. So deployment is going to be very hard and painful. Done.
Yeah.
So
what you've seen here is basically Itai said to this environment, okay, take what you've prepared earlier, like the compiled environment, and push it to the server. That's it.
Yeah. So now it's deployed, but it's not active yet because we might have other deployments. We don't want to interrupt anything. So what we need to do is activate it, and now it's active. So let's see what it can do.
Active meaning waiting for events, right?
Yeah. So we've got our Slack channel ready here, which is a lot of fun. And we made a repository. So I want all you to meet Pepper. Say hi, Pepper. Great. They should have said meow, Pepper. We won't understand. Anyway, we want to edit this repo, and we're going to say Pepper is very cute. It needs to be documented, I think. So we are going to commit this change and create a PR based on this. and we are creating, and then create the PR. And now, hopefully, the DT are good to us, and they are good to us. Thank you, demo DTs. We got some stuff happened here. First of all, we got the message that we wanted in the Slack channel. I think that deserves an applause.
Yeah, it worked.
Thank you, Kittehs. Yes, this is the simplest stuff. It's going to get spicier. And we got something here called the session. Chaim, what is a session?
So a session is basically like a run inside our server, right?
Yeah.
Like a workflow that
You can map it to one session is one workflow in Temporal. Yeah,
Yep.
I think that's enough. That's clear enough. We can go home? Okay, no, okay, sorry. So you notice that we got a session that invoked because of an event. We can see the event, okay? And the event is actually all the ugly JSON stuff that you're getting from GitHub, which is a very complicated API, I must say, but we all know and maybe love it. And we got the session itself. Look at this little cool button. I hope you see this is the temporal thingy. If we press on it, we can see that it actually ran as a temporal workflow, which is pretty cool. Now we can see even deeper into it. And this UI is rough on the edges, so you'll see a lot of JSON. I hope you like JSON. And you can see that the session was completed. You can see that what are the states that it went through. And you can also see something very interesting, this thing. Remember we told you we are running anything as an activity? We're not doing only that. We are also showing all the inputs and outputs of everything that we run. So we called Slack with this channel ID and this message, which is just the URL of GitHub. And we got, for example, back something called the TS, which is what Slack calls a timestamp, but it essentially uniquely identify every message. I want you to remember this TS for now.
Yeah.
Okay?
Yeah. So what's so cool about it, what you've just seen? Look, you didn't write any line of code, right? It's just
no hands.
Chat, post, that's it. Behind the scenes, it collects everything. So if you have an error, which might happen, who knows?
Yes.
Or you want to debug it.
I hope no error will happen today.
Yeah, or you want to debug it, or you want to see retroactively what happened. So you have it, like all the information is there. Then you can build dashboards and see how much time function took and so on. So there's plenty of data there. No work at all.
So notice that this is how much time it takes to write and configure. 30 minutes, if you like. And it took me about a week in Leaf to do this, and I'm not really a slow engineer, I hope, or I think I'm modestly decent. So let's see what we can do to make it more interesting, Chaim.
Okay, so you know what? Let's do the following. Let's say that we will poll the GitHub every 5 seconds, like to make it a durable workflow. Let's poll it and update the Slack upon any change. And if it was terminated, let's just kill the workflow. We're just finished.
You're very violent. Okay, so let's see what we can do to make it slightly more interesting. So give me one moment as I call up the second example. And now you can see that we changed a few stuff here. Now it's getting a bit more interesting and a little more loopy, if I may say. So we did all the original stuff, all the stuff that we did till now, but now we're keeping the timestamp. Okay, we're saving it, we like it. And now we are going to poll the workflow every 5 seconds, and as long as it's not either close or merge. And we are asking the workflow, how are you doing? How is the wife and kids and everything? And then it gives us the results back, and we are updating the chat, the message that we sent back using the timestamp we used earlier, with the state of the workflow as well. Because we want to keep updating to keep the people, okay, no longer need reviews, it's closed or merged or whatever. Right? Now, there are several kinds of magic happening here. One of them is what I told you before. This, and this are running as activities. Yes. And some of them would write a side effect, but it doesn't matter really now. And an activity is something that I don't see any word saying activity here. Do you see it, Chaim?
No.
And am I here? I know I'm getting old, but it's not that great. So we do it for you. You don't need to care about this stuff at all. We just create the activity for you where they need to happen. And we'll do all the further optimizations that need to be done later on. Another thing, which is the greater magic, we are not storing this everywhere. Do you see anything state storage that we usually do for distributed systems? Because we're afraid something will say crash here. If you crash here, what? We are losing the TS, right? No, we don't. Good people, you know, they're smart. I like them. So what happens is the temporal will replay the workflow. And because we are deterministic, and there is no way to escape determinism here in our system, what happens is we will rebuild the timestamp from the results of the activities that already ran and use the same time step later on, which I think is quite awesome. It correlates well to what Maxim talked earlier about durable execution. And let's just focus on like the straightforward workflow execution and not messing with events and state storage and all this stuff. I want to see this running. I want to believe it's running. I want to believe. So what we'll do, we're going to just make another deployment, which we know it's a very hard process, and we're going to switch to it, and now it's active. Okay? So let's go on. And you know what? We can do something even more interesting. We already have a PR created, right? Let's go to the previous deployment and use the previous event to send it to the new deployment. What's happening here, we created a new deployment, and we are just going to resend the event we got earlier and feed it to the new deployment. This is very useful for testing or error mitigation or stuff like that. Doing something like this in today's system, I have no idea how to do it, and it requires quite a lot of effort. So we're going to resend it, and we see that it's running now. You see that the session is running using the same event, and you can see it's even sent the same 79 pull requests with the state open. So I think this is quite impressive and deserves an applause for Chaim.
Yeah. Is it done?
Thank you.
Yeah.
No, it's not done. It's open.
It's open.
Now I'm going to close the PR.
Let's close it.
And I'm going to say close because Pepper knows it's cute. It doesn't need a reminder. It will become too spoiled. And you see now it's going to be completed when the 5 seconds will pass. There you go. The second event is just a random event that we got from GitHub. The PR was closed. So this is running great, I think.
Yeah.
Are we happy and we're going home?
Yeah, that's amazing. Think about it. If you're a developer and you don't know necessarily temporal and all of this, so you just write code, right? You're not even familiar with what's inside. And hey, this is cool.
Yeah.
Right?
It will make our life easier and we can go home earlier, but we're not going home yet.
Yeah. And maybe for you guys that you know temporal, maybe it's not such a big deal to write, but actually there's a whole bunch of people that are not familiar with temporal and would still love to use the power of temporal. That's it.
Yeah. Now
okay, so let's make something even more cooler. So let's do the following. Every 15 seconds, if after 50 seconds the PR is not closed, let's go to a Google Sheet, pull a list of people on call, and just randomly send one of them a message just to make sure that he will close the PR, right? Yeah. Somebody has to take care of this eventually.
Yeah, 15 seconds is enough time to review our code. It's very simple. Obviously, it's very, very, very good. So let me switch to, again, the third demo. Right now, the code becomes much more interesting. It's getting more and more interesting. But first, I need to adjust the manifest something because now we are going to integrate with Google. We're going to integrate because we're going to read this very complicated on-call schedule, which contains Itai, Chaim, Daniel, and Effie, all the people who are very diligently work on that. And we need to connect to it. So we are going to add a name and Google. This is a new connection. I will talk about the token in a moment. And we're saying that this is from Autokitteh Google, and I made no mistake. But now the token, we need to authenticate to Google. We need to say to tell Google to trust us. We are okay to get this data. So we're going to our Autokitteh server, and we're looking at all these nice integrations, and then we're going to Google, and we're going to our house dance, do the house dance to let them authenticate with us. And it does it, and because we have already got the evil Google cookies in our system, it completes it immediately. We are going to copy this token, And this token actually represents the authentication that was done to our system. It does not expose your data. It's just a randomly generated token that you synchronize with our system. So we got this going for us, and now we need to apply this. In order to apply it in integration, everything is fine. And I'm going to speed up because we don't have much time.
Right.
And we go back to the file, and we're going to see what we change here. So there's a few things we did here, and I'm going to go over that very quickly. And I'm sorry for that. First of all, we're adding this request, which is some kind of, let's say, persistent counter that is shared for the entire environment, that we can actually manipulate and have some kind of observability and even use it inside the system, or even to communicate between workflows. This is just one mechanism that we added.
Think about it as a global variable for multiple workflows.
Yes.
If you don't have this, you need to have some kind of a database that the workflow will connect to and read.
Yeah, and you don't need database, full-blown database for everything. We got another counter that's saying how many times we pull this PR. And then we're going the old familiar loop. And then we're saying if we every time that we actually pull the PR and it's still not closed or something like that, we're going to read the data from the sheet. We're going to apply a very, very sophisticated AI algorithm to pick someone who is more suitable, which is essentially just a random number generator. We are going to look the user by email and then send the chat post message and update to mention this person in the channel. Right, Chaim? Yeah, let's see it running. And again, deployment is fun, which is very weird to hear if you're usually in DevOps. And we're going to create a new PR. So let's go here and we'll edit this picture and we'll write meow. I think this is very good. So we're committing, creating, propose. And GitHub is sometimes don't understand that they want to create a new PR for some reason. We'll go here. And we create a pull request. And we're going hopefully to get a message. Yes, we got 80 open. You see that it is still running. Now we're going to wait and to see if in 15 seconds someone is being mentioned here. Let's see who. Any bets if it's Itai, Daniel, Effie, or Chaim?
Let's see. Who knows?
It's
random. There. Oh, God.
What?
Itai, you punished me.
I got an error. Oh my God. Oh my God. Oh my God. That's not good. Not during a demo, right? So we'll go to see and see what the error is. And the error is Google API. It tells try to read what the error is. For request entity was not found. What did you do to my sheet? Oh, that sounds bad. Okay, so let's see. Oh, I did a mistake here. I'm going to remove this.
That makes sense.
And now we're going to deploy it again. That was not painful as I was afraid I would. Now I didn't need to create a PR. I'm going to do it again. And we're going to see that it's running. Great. Now let's see if it actually mention anybody now. So let's see about this one.
So it's waiting for a couple of seconds to discuss. Then let's see who is the lucky one.
Effie won.
Effie won. Okay.
But he's on vacation. He's not going to answer right now. Yes. He got the right idea. Yes. You'll get some stickers later. Everybody got stickers outside, by the way. Yeah, Chaim, let's
wrap it up. So, by the way, what you've seen, this error, actually we were expecting, frankly.
Really? I didn't.
Yeah, I think so.
You're a criminal.
Yeah, but the purpose is to show you that you can code things and you can debug them and you have all the information. Now, go ahead and try to do this on your own, right?
Yeah.
Good luck with that.
Good luck dealing with deployment systems and debugging on the cloud. Here, you don't need to do almost anything. You just deploy, and that's it. I mean, there's a problem. You can do many more interesting stuff and many more testing ideas. We will be very, very happy to show you more how to use it and play with it. Yes, fine.
So let's just wrap it up. So what we've just shown you. So we show you a way to write in code, right? Regular code, workflows or automation, call it whatever you like, that are reliable, long-running, with all the, what Itai calls batteries included, meaning simple connectivity to external APIs, visibility, all of those other stuff, and very simple deployment, right? You just deploy the server and just put stuff on it, and that's it. So we showed you how we can simply make create a connection. We showed you this with Google, right? Just take the authentication, just put it in, we're done. Simple development in code, right? No, not too much hassle. We showed you long-running automations with the sleep and with while loops, and we can do it with for loops, if, thens. It's versatile. You can do whatever you like, unlike many other automation platforms which are no-code or low-code, which have their limitations. We showed you state sharing between workflows. Actually, we did not spend time enough on that, but there are parameters that were shared, and actually one... Done?
Yeah. So let me say one thing. This is only the tip of the iceberg. There are a lot more stuff that we can show you even right now, but Jessica is saying that our time is almost up. 5 minutes, that's for questions. They will want to ask questions.
Yeah.
And I'm not giving paper away. And we are going to hopefully open source it in the next few months when the code will be a bit more mature. And yes, Chaim, anything else?
Yeah, we're going to open source it so you can write it on-prem or cloud or whatever, and eventually we hope to build a SaaS platform for this, so you can actually put your own automations as code. By the way, one of the problems we hear from developers is that they want to write automations, but they also want it as part of their CI/CD, so they want it as code, so you can manage versions and so on. By the way, we didn't show you how we manage versions here. Well, we kind of, because we switched between workflows and it automatically switched to another code. But
there's a lot of cool stuff that we'll be able to show in the future, and that in a few days if you talk to us. So please take out your phone and scan this QR. We'd really love to hear from you, any use cases. Good, all of them. Everybody is taking out the phone. That's good.